And welcome to mathgirl.org. I know you hear that music in the background. That's like my theme song. Welcome to Adding and Subtracting Radicals. It's me, Math Girl. Let me put my little heart up there. Today we're going to talk about how to add and subtract radicals. Well, before we do that, let's talk about how to add or subtract variables. Remember way back when we did Algebra 1, your teacher taught you that if you had 2x's and you added 3x's, the answer would be 5x. And then they tried to complicate it and they said 2xy's plus 3xy's. Well, guess what? That's still 5xy's or xy's. I don't know if you've met my dad yet, right? 2m squared plus 3m squared is 5m squared. So as long as the variables look the same, you are allowed to simply add the coefficients. Well, if you think about that, what do you think is going to happen when you have 2 radical x plus 3 radical x? I know you guessed it because you're really smart. It's 5 radical x. And that's always going to happen. As long as you have the exact same radical being added, you can always just add the coefficients. So what's going to happen when you had 2x plus 3y? Remember that you couldn't do it because since the variables were different, it was simply like a matter of rewriting the problem, and you thought it was like the greatest math trick ever, you know? Well, same thing happens when you have radicals. If I have a 2 radical x and I'm trying to add to it a 3 radical m, because the radicals are different, we're really not allowed to combine them. The math police does not like that. You know, they start hanging out by my door. The answer to this math problem is exactly the same thing again. 2 radical x plus 3 radical m, which leads me to my very big idea. You see, radicals act like variables. So if you could add the variables, you do, and keep the coefficients. If you can add the radicals, you do. Same thing, and the coefficients play with each other. So now, let's look at a couple of questions that are going to seem so easy, you're going to wonder why your teacher didn't teach them to you in kindergarten, right? So 5 radical 3 plus 2 radical 3, you guessed it, is 7 radical 3. 8 radical 6 minus 5 radical 6 leaves me with 3 radical 6. 6 radical 2 plus radical 2. Now don't go switching those 2's to 4's. This isn't multiplying. That was a different video. I had a different theme song back then. 6 radical 2 plus radical 2 means we have 7 radical 2's. Now these 7 radical 2's can go hang out with the 7 radical 3's from the first problem. What about a little subtraction? 3 radical 7 minus 9 radical 7. Don't get scared with the negatives. I'm still allowed to do that. This becomes negative 6 radical 7. And the last problem, what if your teacher tries to trick you with variables and radicals at the same time? Oh my gosh, information overload. Well, don't get scared. It's the same thing we've been doing all along. If you have 7 radical 2x's and you're trying to add 3 radical 2x's, that means you're going to have 10 radical 2x's. Remember, radicals act like variables. So let's do a couple of examples. What were you going to do here? Were you going to try to put these together? You're not allowed. The answer to this is radical 3 plus radical 6. Remember, since the radicals are different, we really can't combine them. So what about here? Oh, you think I'm going to do the same problem 2 times in a row? You know I'm not going to do that to you. I hope you notice that this radical 12 can actually be simplified. You see, if it's not in fully simplified form, you're not really allowed to add them. So at first glance, it looks like you can't combine these. But if you think about it, the radical 12 is like saying a 4 times 3. And we talked about the perfect squares being allowed out of your radical sign. But when it comes out, you know, it can't come out like a 4. That would be way too confusing. When it comes out as a 2. So our math problem is like saying 3 that was already there, the 2 that came out because of this 4, and then that radical 3 gets to still hang out inside the radical sign. Our problem is 6 radical 3. So back to the story. What happens when you have 5 radical 3's and you try to add them to 6 radical 3's, you get 11 radical 3's. Now, if you need to see that again, sweetie, rewind the video. I'm not doing that again. All right, let's try this one. At radical 8. Now, how many times have you seen that radical 8, right? By now, you should know that that always simplifies to 2 radical 2. So 2 radical 2 plus 3 radical 2 is going to give me 5 radical 2. Now, sometimes, like this first problem, it looks like you can't do it, and you're right, you can't. But other times, it looks like you can't do it, and you actually can. Always look for that variable, that radical that you can simplify. All right, last problem, because seriously, I need to go home and watch Survivor tonight. I'm going to try to add these three numbers together, or combine, because I see that negative sign. But remember, you can't combine them unless they're totally simplified, so that you can try to identify what works. So let's do this real quick. This is 3, and then this will be radical 4 and radical 3, so it's still radical 12, minus 2. Radical 9, radical 2, so it's still a radical 18, plus 6, radical 9, radical 3. I'm going to clean this up a little bit. So this is 3 times 2 times radical 3, minus 2 times 3 times radical 2, plus 6 times 3 times radical 3. And our new math problem is going to be 6 radical 3 minus 6 radical 2 plus 18 radical 3. And if I look closely, it turns out that this last term and this first term have the exact same radical glued to the back, like a backpack. So our problem becomes 24 radical 3's. And don't forget, I still have to reduce this by 6 radical 2. Well, you know I love you, but I gotta go. It's Thursday. It's time for me to watch TV. Talk to you later. I'll see you soon.